I welcome all of you in my channel and in this video in which I am going to solve a two-sample t-test for means for a special unidirectional case where mu1 is greater than mu2. You can read this question statement to save the time. I just starting the part A statement. Is there any evidence to support the claim that higher baking temperature? So we have two baking temperatures 95 degrees centigrade and 100 degrees centigrade. So higher baking temperature results in wafer with lower mean photoresist thickness, and these 8 response variable at 95 degrees centigrade and these 8 response variable at 100 degrees centigrade, these are basically the mean of photoresist thickness. Now this question is saying that at higher temperature we get lower mean value, so mu1. So we have to prove that mu2 is less than mu1 or mu1 is greater than mu2. Let's formulate the hypothesis based upon this question statement of part A. First of all, write what is mu1 and mu2. So mu1 is mean photoresist thickness at 95 degrees centigrade. Mu2 is mean photoresist thickness at 100 degrees centigrade. Based upon the question statement, I have written the null hypothesis represented by H0 and alternate hypothesis represented by H1. We always keep the equality symbol in our null hypothesis, whereas the statement which we want to prove we always write in the alternate hypothesis. So mu1 is greater than mu2 as per the question statement I already discussed. Now I discuss the selection of test. I have selected two sample independent t-test to solve this problem. Why I have selected t-test? Because I haven't given any information regarding the population standard deviation or population variance. So this is the reason behind the t-test. Now why two samples? Because I have provided two samples 95 at 95 degrees centigrade and 100 degrees centigrade. The word independent because both of the sample haven't any one-to-one relation with each other and both samples are independent of each other. There is another type of t-test that is known as dependent sample or paired sample t-test. This is the formula in which I have to calculate the T naught or test statistic, but I want to know about what is a y1 bar. So it's the mean of sample 1, y2 bar it's the mean of sample 2, n1 sample 1 size, n2 sample 2 size, and sp is the pooled standard deviation of the two samples. So n1 is equal to 8 and 2 is equal to 8. Then y1 is the mean of sample 1. To write the all of the digits is very time consuming in the exams as well as in the assignments. So the technical way is to write the first value plus second value, then plus 3 dots, and then after that like this is the standard way, plus and then the last value 8.315, this one. And same is the case for the second sample. I will write 5.623 plus 6.748 like this. Okay, then plus sign, then 3 dots, plus, and then the last value. This is the standard way of writing. It will save you too much time during the writing or paperwork. However, please don't skip any value in the calculator. Please include all of the values during the calculations. I got these two mean values. Then I will solve SP pooled standard deviation. You can see this is the formula, and from this formula it is quite evident that it is basically the joint variance of both samples, but so far we have to calculate the variance of sample 1 and variance of sample 2. This is the formula for the variance where xi is the individual value minus x bar is the mean value. So I have written the formula. 11.76 is the first value minus 9.37 mean, then 7.089 second value minus mean, same is the case, the standard way of writing, then 8.315 minus 9.37 whole square divided by n minus 1. So 4.01 and 2.54 are the variances of sample 1 and sample 2 respectively. Now I will solve pooled standard deviation. The SP value comes out to be 3.48. Now I will solve the T naught value, and the T naught value comes out to be 2.65. Criteria, interpretation of the results, and conclusion will be discussed in the part 2 of this video. Thanks a lot for watching this part.